Alrighty, so today is simply guided notes. These notes look a little different than our normal notes. That is why it's just guided. There's no assignment that goes with it. So let's just get right into it. Okay, so this first box right here is simply some rules. So it's showing us a function or an equation in vertex form. It's identifying parts of that equation. A is going to determine which way the parabola opens up, either up or down. So if it's positive, meaning greater than 0, it's going to open up. If it's negative, it's going to open down. Okay, so then just a couple other things telling us the horizontal shift, left and right, which we've talked about this unit. Inside the parentheses is always left and right. Okay, vertical shift is on the outside, plus or minus, going down. And then this part we actually haven't talked about, a stretch and a compression. We are going to talk about it on our notes today, but I will tell you that stretch and compression is not going to be on our test for this unit. Okay, so let's go ahead and fill these out. So looking at box number 1, it says, without graphing, answer the questions about the quadratic function in the boxes. Okay, so here is our function that it's giving us. If rewriting this equation in vertex form, meaning this form right here, okay, we want to know what A is, what H is, and then what K is. Okay, well, A is always our leading coefficient. So in this case, A is going to be 3. Okay. If we were to rewrite this x plus or minus something, well, we don't have x being added or subtracting to anything here. Let me just zoom in just a little bit so you guys can see it a little better. Okay, so h is actually going to be 0 in this case because we don't have any plus or subtracting anything there. Okay, and then k is on the end. It's on the outside of our parentheses. So in this case, k is going to be -4. Beautiful. So we identified A, H, and K for this given function right here. Okay, now we can identify the vertex. Well, we know, you guys, we've already talked about this, where the vertex is H comma K. Okay, so in this case, our vertex is H, 0, comma K, -4. 0, -4. Okay, now we want to know if the graph opens upwards or downwards. Well, our leading coefficient is a +3, so it's greater than 0. So it is going to open upwards. Do a different color. It's going to open upwards. Okay, compared to the graph of y equals x squared, or just our parent function, the graph is shifted, okay? Let's see, the graph is shifted. So this is what we've talked about, our vertical shift right here. 4 units, and because it's -4, 4 units down. Beautiful. First box done, filled out. Okay, let's go to box number 2. Here's our function that it's giving us right here. It says, if rewriting this equation in vertex form, our A is our leading coefficient, which is actually going to be this invisible 1. H is on the inside. That is going to be 3, and it's a reason it's a +3. If you guys remember way back when we talked about vertex form, so this negative in the form actually tells us to flip the sign. So because it's already a negative here, changes to a positive. And then K is on the end, +1. Okay, well that means our vertex is going to be H, which is 3, comma K, 1. 3, comma 1. Okay, now we need to decide if the graph opens up or down. This graph opens, our A is positive here, +1. So again, it opens upwards. Okay, and compared to the parent function of x squared, which is what we're talking about this unit, the graph is shifted 3 units to the right. Remember, whenever you see a minus, it's to the right. And then 1 unit up because of that +1 on the end. Beautiful. Okay. Number 3, box number 3. Okay, it gives us our function right here, and then it says find a function g of x which shifts f of x 2 units to the right. Okay, so whenever we're talking about 2 units to the right, that is going to affect this number right here. Okay, so because it wants us to shift it 2 units to the right, that would mean it would be going, I don't want to say to the left, but we're actually subtracting 2. Okay, so I'm actually going to put that, subtract 2 more from whatever that number is. Okay, well, -4 minus 2 more, -4 minus 2 is going to give us -6. So now we want to write the function. So g of x, this is our new function. Still have our 2 as our leading coefficient. The only thing that's changed here is now it's -6 squared minus 5. So there's our new function that's been shifted 2 units to the right. All we had to do was take that -4, subtract 2 more, because we moved it 2 units to the right, and there's our new function. Okay, now it says find a function h of x which shifts f of x, so our original function, 3 units up. So now up and down we're affecting that number right here. So 3 units up would mean we are adding 3. Okay, so I'm going to say add 3 when we're shifting it 3 units up, which means -5 plus 3 is going to change to -2. Okay, so now h of x, this new function, everything's the same in our original function. We're back to -4 squared because now we're just shifting it up, but -5 changed to -2 because we had to add 3. Great job. Okay, last one, it says find a function h of x which shifts f of x 1 unit up and 4 units left. Okay, so this means we are affecting everything. Okay, 1 unit up means we are adding 1. Okay, so I'm going to write this down here, add 1. And then 4 units left would mean we are, let's see, we are subtracting, yes, yep, 4 units to the left. No, that would be adding. Yep, 4 units to the left. And we are also adding 4. Okay, so we're adding 1 to our outside because that's up and down, and then we're adding 4 to the inside. Okay, so this h of x, 2 doesn't change in front, but then we have x, and a -4 plus 4 would just be 0. So now I just have x squared, and then -5 add 1 would be a -4. And there's my new function. Beautiful. Okay, let's look at box number 4. Alrighty, so we're given our original function right here. Find a function g of x which shifts f of x 5 units down and 1 unit to the left. 5 units down and 1 unit to the left. So that means 5 units down, we are subtracting 5 from the number on the outside. And then 1 unit to the left, we are adding 1 to the number on the inside. Okay, so, sorry, just kicked the table. Okay, so now I have g of x, which is my new function. -1/2 doesn't change, but 3 add 1 now changes to 4 squared. 4 subtract 5 changes to -1. And there's our new function. Okay, now it says, what is the vertex of g of x? Well, we can just get that with our h and our k here, 4 and -1. The only thing we have to do is change the sign on that 4. So that's going to change from +4 to -4. -1 stays the same, so our vertex, -4, -1. Okay, the last question says, is the vertex of g of x a maximum or a minimum? Okay, we find this by looking at the leading coefficient. Because it's a negative, that means that our parabola would look like this. Since it's a negative, the arrows are pointing down. Okay, our vertex would be right there at the top, meaning it is a maximum because it's at the top of our parabola. Awesome job. Okay, let's turn our paper over. All right. Okay, let me zoom out a little bit. All right, for this page, it says, graph the following quadratic functions using transformations. Determine the vertex v. The graph of y equals x squared is shown as a reference. Okay, so it's giving us this little parabola. Use the tables as needed. Okay, so let's see. I kind of don't think we need the tables, but we'll see. Okay, so first thing that I notice is that I see this -4 on the outside of the parentheses. So that is going to tell us to move down 4. So that means I'm going to take this point, this 0, 0, and move it down 4 spaces. 1, 2, 3, 4. Okay, now here's where the stretch and compression comes in. So because we have this 3, usually we would just go up 1 and over 1 on both sides and we'd be good there. But because it's being stretched by that 3 in front, we're actually going to go up 1, 2, 3 over 1. 1, 2, 3 over 1. And this is what makes it really skinny. Okay, so now we can graph that. So instead, we see that it's been moved down 4, but it's also kind of been stretched a little bit. Okay, so that's where that stretch of 3 comes in. So I'm going to go ahead and label that stretch 3. Now, I will tell you, the stretches and compressions will not be on your test. So if that was kind of confusing, don't worry about it. Okay, the last thing we want is the vertex. Okay, well, our vertex is right here. And that point is 0, -4, which we can just write here. 0, -4 is our vertex. Awesome. Okay, let's go to number 2. All right, so we're given our function. And this one I can actually really easily see my transformation. So we have a -3 on the inside. Inside is left and right. Okay, well, -3 tells me I'm going to take them to the right 3. And then I have this +1 on the outside, which means I'm going to take them up 1. Okay, so that means I can take my vertex, go right 3, 1, 2, 3, up 1. There's my vertex. You can do that with each point. And then it would move right there. Okay, so there is my transformed function. We didn't even have to do anything else. No stretching or compressing on that one. The only last thing I need to do is identify the vertex. This coordinate point is 3, 1. So 3, up 1. Awesome. Okay, box number 3. All right, so I see some transformations. So on the inside is left and right, and this one is going to go to the right 4. And then on the outside is up and down, down 5 because of -5. So I'm going to take each one of these little points, boom, boom. You can see them easily on your graph. I'm going to move them. Okay, so I have, in fact, I'm just going to move the vertex right now because we actually do have a stretch. I'm going to label that a stretch of 2. So I'm just going to label or move my vertex. Okay, so to the right 4, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5. There's my new vertex. But instead of going up 1 and over 1, like those points would suggest, because it's been stretched 2, instead I'm going to go up 2 over 1, up 2. Okay, and you'll see that it kind of makes it skinnier than what it was, or it's been stretched. Okay, the last thing we need to identify is the vertex. That's this point right here, 4, comma, -5. Beautiful. Okay. Number 4, I see some transformations. Let's go ahead and focus on those first. Okay, so +3 means I'm going to the left 3 on the inside, +4 on the outside means I'm going up 4. Okay, from my points, I'll go ahead and just focus on the vertex because I do have what we call a compression, and that's because it's a fraction here. Okay, so now I have, let's go to the left 3. 1, 2, 3, and up 4. 1, 2, 3, 4. Okay, now here's what we haven't talked about, and that's okay. So if this next part's confusing, that's okay. So because this is a fraction, 1/2, that means we're going to compress it. Okay, think like shrink it, make it smaller and fatter. Okay, and also we have a negative. This is where the reflection comes in. So usually we'd go up 1/1, but now we're gonna go down 1/2. Down because of the negative, over 1/2 because of the 1/2. Okay? And we have do and do. All right, so this parabola has been made fatter and it's been turned upside down, so now it's going downwards. Okay, the last thing we need to identify is the vertex. -3, excuse me, up to 4. -3, 4. Awesome. Okay, let's go ahead and do this guy. Inside is left and right. Plus means we're going to the left, 1. -1 on the outside means we're going down 1. So grabbing my vertex, my original vertex, I'm just going to go left 1 and down 1. Okay, now this guy right here, this negative in front, that means it's been reflected. Okay, so instead of going up 1 and over 1 like we usually do, now we're going to go down 1 and over 1 on both sides, down 1, 2, 3, over 1. And there is my new parabola that has been moved to the left 1, down 1, and reflected, meaning it's now pointing down. My vertex is going to be -1, -1. Awesome. Alrighty. Okay, last one on this paper. The only transformation as far as left and right, up and down that I see is this -4. Well, that tells me down 4. So grabbing my original vertex, I'm just going to move it down 4. Okay. And then I see that I have a compression. So that means instead of going up 1 and over 1, I'm going up 1/3 over 1. And then from there up, let's see, then the other points would be 3, -1, and then -3, -1. Okay, so we see that it got like fatter, like wider. And that's because of that compression. Compress. Okay, last thing we need to identify is our vertex, that guy right there. It is 0, -4. Beautiful. Let's go to our last page. All right. Okay, so looking at our first little box right here, it says, write the equation of a quadratic function in vertex form, which has been shifted 2 units to the right, 6 units up, and has a vertical stretch by a factor of 4 compared to y equals x squared. Okay, so a lot of mumbo jumbo. But let's go ahead and just write our f of x, same thing as like y equals. Okay, f of x equals, okay, whenever we have stretched by a factor of 4, Okay, that means we're going to have 4 in front of our parentheses. Okay, left and right, so it says 2 units to the right is always going to be on the inside of our parentheses. Right means it's negative, so minus 2, 2 units to the right. And then 6 units up on the outside, plus 6. Beautiful. Okay, we can identify the vertex without even graphing it yet. Okay, remember the vertex is always h, comma, k. Change the sign on your h, so negative 2 changes to positive 2, comma, 6. All right, so now it wants us to graph it, so we can go ahead and graph our vertex first. 2 up to 6, and then vertical stretch of 4, that means I'm going to go up 1, 2, 3, 4, over 1 on both sides. And there we go. There's our quadratic. Beautiful. Okay, number 2, it says the graphs below represent 2 functions. One is a vertical compression and the other is a vertical stretch. Label them as such. Okay, well this one's actually not too complicated. We see that this box right here is pointing to this taller, skinnier one. Well, whenever it's gotten skinnier, we know that one is the stretch. Okay, and this one right here, this box, is pointing to the one that's gotten wider, and that one is the compression. So I'm just gonna write compress. Beautiful. Number 3 says, write the equation of a quadratic function in vertex form, which is a reflection of the function across the x-axis. Okay, so across the x-axis, it's giving us this original function, but the only transformation is a reflection across the x-axis. Well, this one's actually not too bad. So first we're gonna just start with our y equals. You always start your functions or your equations with that. And because it's a reflection, all we have to add is a negative in front of these parentheses. Everything else stays the same. We just had to add that negative because of that reflection. And we are done. Okay. All right. Let's go ahead and look at number 4. It says, find the equation of this parabola. Sweet. Okay, so first thing we want to grab is our vertex. Our vertex is at the coordinate point -3. I know this is really small to see. -3 down to -3. Okay. And then if I see that it's going up 1 and over 1 to my next points, that's awesome. And it's going up. So guess what? The only thing I need to write here, y equals, my vertex would be -3, which we always change the sign on the first one. So +3 squared down to -3, -3. Boom, we're done. And our last one. Okay, so it's giving us 3 graphs here. It wants us to identify which of these many equations are those graphs. Okay, well, let's go ahead and look at the one on the very left right here. First, grab the vertex. My vertex is -4, -2. Okay, so that means I need the equation with a +4 on the inside. So it is either going to be E or B, because that -4 is going to change to a +4. Okay, then it went down to -2. So we don't change the sign on it. So because it has the +4 and the -2 right there, check. That one on the very left is E. Okay, let's look at the one in the middle now. So my vertex is 0, 0. And we can see that it's really skinny. It went up 1, 2, actually it went up to 4 and then over 1. It's labeled kind of weird. 4 and then over 1. So it has a stretch of 4, okay, which tells me it's either A, or F because of those stretches of 4. Okay, well, with my vertex being 0, 0, it cannot have this -2 in it. So I know it's not going to be F. That one is going to be A. And let's go ahead and look at this last one. Okay, well, let's see if we can figure out this vertex. So it's 4 and then up to 2, it looks like. 1, 2, 3, yeah. 4, 2. Okay, so +4 should change to -4 on the inside. Because of that +4, I'm looking for a -4. So that means it has to be C or D. Okay, and then the last thing, this +2 that it lines up with right there. I know this graph is really hard to read. Okay, that means I'm looking for a +2 on the outside, which is right there. So check. That last one is D. And there you go.